What is the value of 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square till infinity? This problem is called Basel's problem, and it was first solved by Euler, and this value comes out to be pi square by 6. So let's see how we can get to the result of pi square by 6. So before starting with the video, please do like, share, subscribe, and to support this video. Now let's start. So clearly we can see that this expression can be written as summation from I is equal to 1 to infinity 1 upon I square, right? So which is also equal to zeta of 2, which is pi square by 6. If you don't know what is zeta function, zeta of s is defined as a summation from I is equal to 1 to infinity 1 upon I raised to the power s. Okay, so this is how you define the zeta function, and this value is actually the value of zeta function at 2. Of course it has no connection with the problem, but still for your knowledge I told that this is actually zeta of 2. Okay, so now let's see how we can evaluate this. So for the evaluation of this summation, I'll be using the concept of Fourier series. If you don't know, let me explain it. So first of all, let me erase this, then I will explain. So suppose you have a function fx and you want it to be written in a linear combination of trig functions sine and cos. So how you write it? So Fourier series is used for that work only. So it is a naught by 2 plus the summation from n is equal to 1 to infinity a n cos n pi x by L plus the summation from n is equal to 1 to, or you can say m is equal to 1 to infinity bm sine m pi x by L, where x belongs to negative L to L, right? So how you will solve the values for a naught, an and bm? These are the constant, these are the basically coefficients. An and bm are the coefficients, and a naught is itself a constant. So a naught is given as the integral from negative L to L fx dx times 1 by L. Okay, and an is 1 upon L integral from negative L to L fx times cos n pi x by L dx, and bm is 1 upon L integral from negative L to L fx sine m pi x by L dx. So if you don't know anything about Fourier series, you can first of all check out my one shot on Fourier series, which I had made around 6-7 months back for BTech. You can check it out, and it is not very difficult to understand. So if you will watch the starting 20 minutes of that lecture, you will understand what is Fourier series, right? So you can check out that lecture. I'll give the link in description. Okay, so this is the basic concept of the Fourier series, and notice that if fx is some even function. What is an even function? F at negative x is equal to f at x. Okay, so this is the meaning of an even function. Okay, so in that case, bm, this is an even function, this is an odd function, sine is an odd function. So it means that the integral from negative L to L of an odd function will be equal to what? This will be 0. So if fx is an even function, then in that case there is no cos, there is no sine term. Okay, if fx is even. Okay, so in that case we can neglect this term and we'll just work with these two expressions. Okay, so for our calculation of pi square by 6, that is the summation, we will assume the function as x square. So let's see what we get. And since x square is an even function, so we will not get any bm term over here, so we can neglect this term and we'll be just left with this function. Okay, there's no need of this. Okay, so now let's solve the Fourier series for this function. Okay, So we had assumed that fx is x square. So let's see. So a naught is the integral from negative L to L fx dx and 1 upon L. Okay. So let's assume that x is varying from negative pi to pi. Correct? Okay. So what you will get? You will get 1 upon what is L? L will be equal to pi. So pi times negative pi to pi fx. What is fx? Fx is x square dx. Now notice this is an even function. So it's an even function. So you can write this as 2 by pi integral from 0 to pi x square dx. Right? You know this property or not? So we have this expression. So this is 2 by pi times the quantity x cube by 3 evaluated from 0 to pi cube by 3 times 2 by pi. So this and this gets cancelled. So you get a naught as 2 pi by 3, 2 pi square by 3. Okay. So we have fx. Okay, just note this, that a naught is equal to 2 pi square by 3. Okay. Now let's evaluate an. What we get for the functional value of an. So an, of course, it will be in terms of n, right? It will be the integral from negative L to L fx cos n pi n pi x by L dx, of course 1 by L also. So when you substitute L as pi, what you will get? 1 upon pi integral from negative pi to pi of the quantity x square times cos of n pi x by, when L is equal to pi, these two terms will get cancelled, I mean. Okay, so this will be 1 upon pi integral from negative pi to pi x square cos nx dx. Okay, so you get this expression, and again this is an even function. X square is even and cos function is itself even, so even times even is an even function, which means that you can write an as 2 by pi integral from negative pi to pi x square, 0 to pi cos nx dx. Correct? Okay, so let's evaluate this integral now. Okay, so we had got an as 2 by pi integral from 0 to pi x square cos nx, okay, dx. Okay, we had got this expression. Okay, so now we have to apply integration by parts over here. So let's see. Integral from 0 to pi x square cos nx dx. So let's assume this x square as first function and this as second function. So let's apply integration by parts. What is the integral of cos x? The integral of cos x is sin x, right? So this is equal to sin nx, and by the rule we will get sin nx by n times x square evaluated from 0 to pi minus this integral 0 to pi, the derivative of x square is 2x times sin nx by n dx. Correct? You will get this expression. Okay, so yeah, so notice that when you substitute 0, then sin of 0 is 0, and of course x will be also 0, so this will be whole expression 0. And when you substitute x as pi, what you will get? Sin of n pi. What is sin of n pi? Since n is belonging to natural numbers, since it is going from 1 to infinity, so it means that sin of n pi will be equal to 0. So this whole expression is 0. Okay. So you got this as negative 2 by n times the integral 0 to pi x sine nx dx, right? Okay. So you have negative 2 by n. Let's evaluate this integral now. What you get? So again you will apply integration by parts. What you will get? You will get x. What is the integral of sine nx? It is negative cos nx divided by n, evaluated from 0 to pi, minus, what is the derivative of x? It is 1. And what is the integral? It was negative, so this will become positive, cos nx by n, correct, dx, evaluated from 0 to pi. Okay, just keep on checking all these steps, because maybe I can make any calculation error, so please see to it. Okay, and if I make any calculation error, just tell me in the comment section. Okay, so when you substitute, okay, we will see it later. First of all, let's check for this. So when x is equal to 0, then of course this expression is 0. Okay, let's make the limits like this. Okay, so this is 0 minus. Now when you substitute pi, what you will get? You will get x, that is pi by n times cos n pi, correct? Cos of n pi plus, what is the integral of cos nx? This is equal to plus sine nx by n square divided from 0 to pi, and we had already proved that this is equal to 0. Okay, so this is 0, so we have just this expression times this expression. So what you will get? You will get the final result as negative 2 pi by n, and negative will become positive, times cos n square, because n into n is n square, cos of n pi. Okay, now what is cos of n pi? It is 2 pi by n square times negative 1 raised to the power n. When n is equal to 1, it is cos of pi, which is equal to negative 1. When n is equal to 2, it is cos of 2 pi, which is equal to positive 1. When n is equal to 3, then cos of 3 pi is equal to negative 1 again. And when n is equal to 4, then cos of 4 pi becomes 1 again. So it means that it is oscillating like plus 1 minus 1 plus 1 minus 1. Okay, so we can clearly say that this will be the expression for cos of n pi. Cos of n pi is negative 1 raised to the power n. Okay, so we got this expression. So this integral is actually equal to, I should write over here, an is actually equal to 2 pi by n square. Of course 2 by pi we have to multiply, 2 by pi times 2 pi by n square times negative 1 raised to the power n. So we get an is 4 pi, pi and pi gets cancelled, so it will be 4 by n square, this will be n square, okay, negative 1 raised to the power n. Okay, so we got an as this function, okay, in terms of n. Now we are ready to solve this summation, so let's see. So we had got a naught as 2 pi square by 3 and an as this expression. So what was fx? Fx was equal to x square. Okay, so x square is a naught by 2, which is pi square by 3, plus summation from n is equal to 1 to infinity 4 by n square negative 1 raised to the power n cos of nx. Okay, right, we get this expression. Now let's substitute one thing over here, that is the crucial step. Let's assume x is equal to pi. When you substitute x as pi, what you get? Pi square is equal to pi square by 3 plus the summation from n is equal to 1 to infinity 4 by n square times negative 1 raised to power n cos of n pi. Cos of n pi is equal to negative 1 raised to power n again, right? So you get negative 1 raised to the power n. So 2 pi square by 3 is equal to 4, n is equal to 1 to infinity 1 by n square negative 1 raised to the power n times negative 1 raised to the power n is actually equal to negative 1 raised to the power 2n, which is equal to 1 raised to the power n, which is equal to 1 for all n. Okay, so we have got this expression. So we can say that summation as I is equal to 1 to infinity 1 upon I square is equal to pi square, or you can say summation from n is equal to 1 upon n square is equal to pi square by 6. And this is a solution of Basel's problem using Fourier series. Of course, you can find many other methods also. Many people use the definition of sin x over here, the Taylor form of sine series, and then they apply it. But it sometimes becomes really complex. So I feel that using the Fourier series is better in such cases. Okay. So what I've done is that, let me summarize the whole video. I first started with the Fourier series definition that fx is equal to a0 by 2 plus the summation like this, and there was a sign term also, but I assumed that fx is equal to x square, that is an even function. So for even function v of m becomes 0, so due to which the sign term disappeared, so we were left with fx is equal to this expression. And then from the definition of Fourier, from the definition we found the value of a0 and an, which came out to be 2 pi square by 3, and n came out to be 4 by n square times negative 1 raised to the power n, where n of course belongs to natural numbers from 1 to infinity. Okay, and then I substituted back into the original equation, and then I substituted x as pi, and I solve this expression, and I end up getting the summation from n is equal to 1 to infinity of the function 1 by x square or 1 by n square is equal to pi square by 6. And this is how you approach such kinds of problem very easily, right? And many of you might be thinking that how I wrote this expression, include a sign one also. So for that you have to first of all understand the concept of Fourier series, that how we deduce the expression for Fourier series. So please, for that, please check out the one shot of Fourier series which I have already made some months back. I'll give the link in description, and it's roughly around 1 or 1.5 hours lecture, but you don't need to watch the whole lecture. You can just watch probably around 20 minutes. First starting 20 minutes you can watch. In that, all the concepts, all the derivation, that how we get this expression, that derivation I've given, and it is very simple actually. You can understand it very easily. So please check out that video, and if there's any doubt or any calculation error which I made in this video, then please do let me know in the comment section. Till then, bye bye, take care, and all the best.